One of the most important features of any smart home is the ability to detect and react to changes in the environment. I briefly talked about systems being able to detect the state of smart devices in your network, but what about the physical environment? How can the system tell if a door is open or a light is on? The answer to that is sensors. My name is Steve, and this is it-alchemy. Sensors come in all shapes and sizes, and different sensors can monitor a variety of things about the physical world. We can use this information to drive automations in our smart home. I've created a semi-comprehensive list of the most common types of sensors you may want to use in your smart home. There are quite a few, so I've grouped them into categories. Let's go through the different types of sensors and see some examples of how they might be used. First up is what I refer to as activity sensors. These are comprised of types of devices that detect physical changes in the environment. Among these are motion detection. Motion or presence detection sensors detect physical motion within their field of view. Typically, this is done by measuring the movement with passive infrared or PIR, ultrasonic, or microwaves. Some sensors are smart enough to detect even stationary objects by measuring only subtle movements like breathing. Or some can even differentiate between humans and animals. This can be used to detect whether someone is still in the room before running an automation to turn off all the lights. Next up, we have vibration sensors. Vibration sensors convert mechanical vibration into electrical signals that can be measured. This allows it to determine if the object is attached to is being disturbed and to what degree. These are often found around glass break detectors to determine if the window has been shattered, such as if someone is trying to break in. Noise sensors use very small microphones to listen to the ambient sound and convert it into measurable electrical signals. These can be used to detect noise levels and if they exceed a certain threshold, and they can be useful in environments with noise restrictions like apartment buildings, or even to detect a potential party that the kids are having while the parents are out of town. Force sensors are similar to vibration sensors in that they convert the mechanical force to electrical signals. The difference is that they're often used to determine whether or not constant force is being applied. Common use for these types of sensors is underneath mats to detect whether an object is placed on it, such as a doormat for person or package alerts at your front door, or in your garage to determine whether or not a vehicle is present, or even under the bed for activating nighttime automations. Touch sensors are generally either capacitive or resistive sensors that detect if an object is touching the sensor. These are very commonly used for control systems or in the place of physical buttons, such as your smartphone. Weight sensors are basically force sensors, but they're distinct in that they're generally used with a specific amount of force applied in mind, rather than whether or not it's being applied at all. A bathroom scale is probably the most common example of this. Another example could be weight sensors on the pantry shelves, so when you get groceries and start to put them away, you can make an under-the-shelf lighting strip turn red if it's overloaded. Gyroscopic sensors detect the position and inclination of an object it's attached to. These sensors aren't very common in a typical smart home, but they can be used to monitor things like sagging infrastructure, such as an outdoor deck, or even if the mailbox has been flipped open. Proximity sensors are another type of motion sensor, except that they're typically used to measure an object's proximity relative to the sensor. This can be useful for triggering automations that we normally would only run when a person is interacting within a certain area, such as turning on the range hood light when you're standing in front of the cooktop. Contact sensors, also sometimes called brake sensors, usually have two components that trigger when separated. These frequently are used on doors and windows to detect whether or not they're open. Next up, we have air quality. Air quality sensors detect and measure the amount and concentration of various pollutants and gases. These are used outdoors, but often used in smart homes when the air quality is poor. Automations can trigger to turn on the ventilation systems or alert you to open the windows. There's PM 2.5 or PM 10 sensors for smoke and other things. These detect fine particulates in the air. You got smoke, pollen, dust, that sort of thing. There's VO2 sensors that detect volatile chemicals present in the air. These chemicals can be released when you're using gas stoves for cooking or if you spray aerosols, and that can really contribute to poor or even harmful air quality, especially in closed spaces. There's also CO and CO2 sensors. They detect the concentration of both or either carbon monoxide and carbon dioxide in the air. These are gases that can be harmful or even fatal in large concentrations, and they're a cause of concern in your really airtight or poorly ventilated areas. There's also radon sensors. As you can guess, they detect radon. Radon's an odorless, tasteless, radioactive gas that naturally seeps up out of the ground in some areas. Sensors for this are more of a secondary mechanism to alert when there's a leak, and if this really is an issue in your home, I recommend installing a proper radon mitigation system. Nobody likes radioactive gas in their house. Speaking of gas, there's gas leak sensors. And those detect the presence of specific gases in the air by a variety of methods. These are usually combined with warning systems to monitor for leaks in like natural gas or propane or even refrigerant lines. Next up, we have temperature. Temperature sensors can detect the temperature in the vicinity or within direct contact of the sensor. Many temperature sensors can also detect the absolute or relative humidity. These are useful in conjunction with, say, a smart thermostat, as temperature sensors in the individual rooms can more accurately reflect the overall temperature of the house for use in controlling your heating and your cooling systems, or even adjust zone valves for more precise temperature control. Next up, we have water sensors. Water sensors, as you can imagine, detect the presence or quality or even the volume of water or other liquids. We have leak sensors, which detect the presence of standing water. Ones that utilize ultrasonic measurement can even detect minute, slow leaks, such as a leaky faucet or a long-running toilet. This is useful for triggering alerts to potentially costly water damage problems before they get out of hand. One thing that's not also as common is something that I use in my garden is a soil moisture sensor. It detects water content in the soil by measuring the electrical conductivity in the ground, and this will change based on how much water is actually in the surrounding medium. It can be used for setting watering schedules for your garden, for example. We also have flow rate sensors. Flow rate sensors measure the flow of water within the system. This is especially useful for monitoring things like water pressure, such as in the case of rural areas that are on like well water, or in colder climates like up here in Alaska, to alert you if your pipes are freezing up. There's also water quality sensors. Water quality sensors are exactly that. They measure the quality of water within a system. These aren't very common in residential homes, but some monitor pH levels, some detect the presence and quantity of specific dissolved solids like calcium if you have hard water, and in some cases turbidity, which is how cloudy the water is. Again, these aren't very common unless you have pretty specific problems with your water systems, such as like an in-home water treatment systems. Folks that are on well water usually have water softeners and descalers. There's also volume sensors. Water volume sensors are usually hydrostatic sensors that measure the pressure that's exerted on the liquid within a container to determine the volume. Up here in Alaska, propane and natural gas isn't very common in some areas, so one of the primary methods for heating in the wintertime is fuel oil furnaces. These are usually gravity fed by a non-pressurized tank. It's either above ground or it's buried. Hydrostatic sensors can determine the volume of oil remaining in the container. Automations can be set up to monitor the levels and alert when it needs to be refilled. Trust me, nobody wants to run out of heating fuel in the middle of winter when it's 40 below. Next up, we have weather sensors, which come in a variety of flavors, and they monitor for specific weather metrics. Most often, these are built into some sort of weather station that you put out in the yard. They're not just for things like outdoor temperature. In a sense, this is not just at your home either. You can utilize weather services with your smart home to trigger automations to alert you of local weather events. For example, if there will be a drought with water conservation edicts from your local municipality, Lawn sprinklers can be disabled, or maybe the runtime can be adjusted. Energy sensors detect whether or not a circuit is energized, but also monitor the amount of electricity being used. For energy monitors, many smart outlets and smart circuit breaker panels can individually detect whether electricity is flowing and how much power is utilized by a single device or even a whole circuit. This is especially useful if you're conscious of your smart home's energy usage. Turning the power off to devices when not in use can lead to fairly significant cost savings on your energy bill. Additionally, many smart circuit breaker panels can create virtual critical load circuits rather than having to build physical ones, which could be expensive, whereby in the event of a blackout and running off of your battery backup, you can designate which circuits remain powered and for how long. Even adjusting is needed to conserve your reserve battery power for longer outages. Lastly, we have light sensors. These use a photocell to detect and measure ambient light. These are particularly useful for creating automations at certain times of the day or night. For example, turning on the outdoor lights from dusk until dawn, or raising or lowering your window blinds to block out the sun to a certain degree throughout the day. Sensors can be used to detect and measure all sorts of things in your smart home and help you build automations that otherwise may not be possible. Remember that many devices have built-in sensors of various kinds. For example, a security camera might have a light sensor and it might have a motion sensor that can be utilized by a home assistant or another smart home platform for your automations. So having discrete sensors everywhere is not always necessary. As always, please remember to like this video and subscribe to my channel so you can keep up to date on the latest content. We covered a lot of different types of sensors that you may want to use in your smart home. Feel free to leave a comment if there are any that we've missed. I'd also love to hear how you're using sensors in your setup. Thanks for watching.